Hello, dear students. How are you all? Hope you all are doing well. So, today I will start with a story. I am Vidhi Srivastav, your new maths teacher. So, let's start with story. One sunny morning, Ria was walking through her garden with her grandfather. See in the images, it is showing that Ria is walking with her grandfather. As they walked, grandfather pointed at the flowers and asked, "Do you notice something special?" Ria looked carefully and saw that the flowers were arranged in a repeating order: red, yellow, red, yellow, red, yellow. They continued walking and heard birds chirping, chee chee, chirp chirp, chee chee, chirp chirp. Ria smiled and said, "That sound repeats too." Grandfather then showed her tiles on the pathway. The shapes were arranged as circle, square, triangle, circle, square, triangle. This is called a pattern, he explained. A pattern is a repeated arrangement of numbers, shapes, colors, sounds, or objects. At home, when Ria reached, she opened up her notebook and she started writing few numbers like 2, 4, 6, 8. Then what will come after 8? 10, then 12. Then she wrote 5, 10, 15, 20. She realized that mathematics is full of patterns. Patterns help us predict what comes next and what makes learning mathematics easier and more interesting. From flowers and music to numbers and shapes, patterns are everywhere around us. Yes, you are right. So, this is our chapter which we are going to learn. So, we have seen patterns everywhere, wherever you go, whether it is number or anything else. Okay, so today's chapter is pattern in mathematics. It is from Ganit Prakash, class 6. Welcome once again. So, let's start what exactly mathematics is. I hope you all must be aware you are in class 6. We are learning mathematics since we were in pre-nursery. Am I correct? Yes. So, mathematics is a journey or a study of a number, shapes, pattern, measurement, and calculations. It helps us understand and solve problems in everyday life. Whatever we do, there is mathematics. In simple way, we can say mathematics is something that we can use in science, numbers, shapes, or if we see pattern, repeating numbers, then we can use measuring length, weight, time. So I have taken few examples. What are the uses of mathematics in our daily life? So let's see. Shopping. When you go for shopping, you see that there is a bill. Okay, so you can see that there are rates written, prices are written there, and you just add it. So that is also a calculation. You are doing totaling of the cost items. Okay, finding discount offers and everything. Okay, then time management. Since the time you get up and you go to school, you reach school, you come from school, and every time that there is a time management. So, do you follow time management or not? Yes, you have to follow time management. Now, coming to cooking, there is a measurement of everything, measuring ingredients such as flour, sugar, milk. It is not about these things which are given in example. There are many other things you can see while your mom is cooking. She has some measurement or dad is cooking. Okay, now travel. Travel, when we travel, so distance, then speed, time, everything is full of mathematics. Sports, when we play sports, then scoring is done in games, so it is also mathematics. Measuring distance, height, timing, comparing players' statistics means how much he has scored, how better he is from other. Then banking and saving, you can see that in banking it is full of mathematics. Then construction, there are dimension, calculating area, perimeter. Okay, so this is all full of mathematics. Then technology also, it is full of mathematics. Whatever the new techniques are coming, without mathematics will you be able to do it? No. Now coming to the nature, nature is also full of mathematics. See, look at the petals, how they are arranged. They are arranged in a pattern. Okay, there is honeycomb. Okay, this is all mathematics. Look at the leaf, look at the weather forecast. This is all full of what? Patterns, and which is in mathematics. At home, when you eat, okay, so you do half chapati, I will be eating that portion. What? That is also a mathematics. Okay. Other examples are scientific discoveries and experiments. We use mathematics, building a structure and infrastructure, transportation, then technology and communication. Everywhere we are using mathematics. Then economy and banking. You would have heard that finance minister is telling or speaking for the budget. What is that budget? So everywhere they are using mathematics. Democracy and government, what is the percentage of vote you have given or people have given. Then measuring time, I have already told. Space and exploration, when we go exploring the space, velocity, acceleration, time, everything, it is full of mathematics. Now the next topic which we will start, now I am want to tell you that this is the chapter only we have to study. So what is that? Patterns. Patterns are found everywhere in mathematics, as we have discussed also. And now the patterns or the numbers which we have to study are all ones, counting numbers, odd numbers, even number, triangular number, squares, cube, Virahanka number, powers of 2 and all. So there are many patterns in maths. So they occur in natural sequence. These numbers form a foundation of many mathematical ideas. So these are used in real life also. That also I'll tell you how they are used in real life. So we all have learned about even numbers, prime numbers, multiples, factors. There are many special sequences. So let's start with our first pattern of number, all ones number series. What is all ones number series? Actually, it is something like that. If I write 1, 2, 3, 4, 5, I have these 5 baskets and I am uh, 1 apple in this. So, these baskets are in a row or line, what we can say. First basket, second, third, fourth, fifth. And all the baskets have one apple in it. So means every time first is also 1, second is also 1, third is also 1, fourth is also 1 and fifth is also 1 and so on. So this is the number pattern which we have to learn, that all the terms will be only 1, 1, 1, 1, nth term till nth. Nth means we don't know the limit till where we have to put this. Okay, first term is 1, second term is 1, third term is 1, fourth, fifth, sixth, 100, 1000, lakh, all the terms are only 1. Means only 1, 1, 1, 1 object. If we say you make a queue to go somewhere, so you stand sometime roll number wise or height wise. So what happens? One student in in a queue. one after another, one after another, one after another. So this is the pattern. Or this also happens ki in on at the first number one student is there, and at the second number two students are there, third number five students are there. Does it happen? No. Only one students remain in queue. So you can understand by this example. Now the next number in the series is natural number. No, no, please don't worry. What are natural numbers? You need not to worry about that. I just want to ask you 1, 2, 3, 4, 5, 6, 7, and so on. If I have to count. Or when you stand in your class and your teacher has told just count the number of students, how many are there. So you start counting from where? 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. So counting. The number from which we start counting are called counting numbers. And let me tell you, all the counting numbers are called natural numbers. Means natural numbers are the counting number. Whenever we start counting, we start from 1. Or there is someone who starts from 0 also. No. We always start counting from 1, 2, 3, 4, and so on. Is there any limit? Is there any limit of counting? That you can count till only 1 lakh or 1 crore? No. So means we can keep counting forever, infinitely. Okay. So I would like to tell you, if somebody asks you what are natural numbers, all the counting numbers are natural number. What is the smallest natural number? Smallest natural number. Smallest natural number is what? 1. And largest largest natural number. What is the largest natural number? Any idea? I don't know. No limit. There is no limit. So there is no largest number because it is infinite. Now, after natural number, there are whole numbers. Now, again, coming to the topic, what are whole numbers? But before that, I want to discuss. Suppose we have done 7 minus 2 is equal to 5. And 3 minus 1 is equal to 2. And at the same time, I say 4 minus 4 is what? 0. Was it there? No, we haven't learned about 0. So 0 is something which was introduced in the collection of whole number. So means all the counting number means all the natural number plus 0 is what? Whole number. It is the set of whole number. Set, or you can see this is a bag where all the counting numbers are there, and one more number which is added to this series. What is that? 0. Now whole number starts from 0. 0, 1, 2, 3, 4, 5, 6. So what is the smallest whole number? Smallest whole number is what? Smallest whole number is what? 1 or 0? 0. 0 is the smallest whole number. And what is the largest whole number? Is there any idea? No, there are no largest number because we can we can count infinitely. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and all like lakh, 2 lakh, crore, 10 crore, Arabs. So these are what? There is no limit. Million, billion, trillion. Is there any limit? No. So smallest natural number is 0, and we don't know about the largest number. One more thing I want to discuss. Whole number means one. Whole means what? One complete thing. One complete thing. If I am talking about this pizza, so it has 4 pieces, but it is one complete pizza. If I take one part out of this, so we cannot say this is whole. It has a part now, so it is not a whole. So it is also, see, percentage, always complete, not a fraction. So that means this is also not a whole number. No negative number. If I ask you -2 or -2, no, this is not a whole number. I hope everybody is aware now what is whole number. So smallest natural number is 1. The smallest whole number is 0. One more thing. If I ask you, 2 is a natural number? Yes or no? Yes, 2 is a natural number. 2 is a whole number? Yes, 2 is a whole number. If I ask you that all the whole numbers are natural number, all the whole numbers, see, look at the whole numbers. All the whole numbers are natural number? No. All the whole numbers are not natural number. All the natural numbers, all the natural numbers are whole number. What are the natural numbers? 1, 2, 3, 4 and so on. Are these whole number? Yes, it is a whole number. Now, let's see odd numbers. I know, don't be excited. I know that you all are aware what are odd numbers. Yes, when we were in class second, then we also have learned, but now we will use it. See, 1, 3, 5, 7, 9, 11, 13 and so on. These all are odd numbers. Now, see, the number which end by 1, 3, 5, 7, 9 means if I say 29, this is a odd number. If I say 43, this is an odd number. If I say 75, this is an odd number. If I say 221, this is an odd number. Why I am saying these all are odd numbers? Look at the ones place. Look at the ones place. Again and again. Every time it is ending up with what? 1, 3, 5, 7 or 9. 5, 7 or 9. So that means these all are odd numbers. One more thing I just want to discuss about odd number is odd numbers are not exactly divisible by 2. Odd numbers are not exactly divisible by 2. Means whenever we will divide any odd number, suppose I have taken 15 divided by 2, what it will be? 2 sevens are 14 and the remainder is coming 1. So every time there will be remainder. So that means odd numbers are not divisible by 2. Odd numbers are not divisible by 2 exactly. Understood? Okay. Now the next numbers are even numbers. What are even numbers? I hope everyone is aware. I know everybody is smiling. I know, I know. Now let's see. 2, 4, 6, 8, 10, 12, 14, 16. Yes, all the numbers in a simple way, in an easy way, we can say all the numbers which comes in table of 2. Yeah? When we were small, we have learned like this. Now, all the numbers which come in table of 2 are called even number. So now let me tell you one thing. All the numbers which end up by 0, 2, 4, 6, 8. Acha, one request everybody. Whenever I am moving my pen, please see there. Okay? I should be there so that you can understand what I am teaching you. So 0, let's write 20. Ending up with 0 means one's place is what? One's place is 0. This is an even number. 3, 2, one's place is 2. End with 2. That means this is also an even number. 7, 7, 6. Ending with 6. This is an even number. Okay, understood? 3, 3, 8. Ending with 8. This is an even number. So I hope everybody now understood how we can write even numbers. One more thing, even numbers are exactly divisible by 2. Even numbers are exactly divisible by 2. See what I want to tell you. 2 6 is 12. Remainder is coming what? 0. Now let me divide 18 by 2. 2 9 is what? 18. And the remainder is coming what? 0. That means every time when I am dividing an even number by 2, I am getting 0 as remainder. That means that the all the even numbers are divisible by 2 exactly, completely. That means when remainder is coming 0, that means it is exactly divisible. Okay. Now the next number in the series is triangular pattern. This is something new, but don't worry, you will be easily handling this. I know you all are very much intelligent. Am I correct or wrong? Yes. The first number is 1. First triangular number is 1. There is no triangle. But before I want this, I want to tell you equilateral triangle. This is 5 centimeter, this is 5 centimeter, this is 5 centimeter. Equilateral triangle means all sides are equal. So now we start with 1. So 1 is the first triangular number. There is no triangle. Now see first triangle. 3 dots are there. 1, 2 means 1 plus 2 is what? 3. Then the third triangle. 1 plus 2 plus 3. How many dots are there? 6. Okay. Fourth. 1, 2, 3, 4. 1 plus 2 plus 3 plus 4. Together is what? 10. Fifth is what? What should we add to the fifth triangle? 5. Yes. 10 plus 5. That is what? 15. What should we add to sixth triangle? 15 plus, come on fast. I don't know. 15 plus 6. That is 21. Then 21 plus 7 is what? 28. Then next number quickly. 28 plus what? 8 is 36. Next number 36 plus 9 is what? Quickly. 45. 45 plus 10 is what? 55. 55 plus what? I want to ask. 11 is what? 66. So means every time we will add one more number to the series. See, 1 plus 2 is 3. 1 plus 2 plus 3 is 6. 1 plus this 10. Then 1 plus 2 plus 3 plus 4 plus 5 15. Then after 6, what should I add? 27. Then after 28, what should I add? 8. Then 9. Then 10. Then 11. I hope you all are now understanding. See, after this, please draw the seventh triangle quickly. How we will draw the seventh triangle, beta? First 1 dot, then 2 dots, then 3 dots, then 4 dots, then 5 dot, then 6 dot, and what? How many dots we will add here? 1, 2, 3, 4, 5, 6, 7. Am I correct? 7 dots I have added. Okay. Then 8 dots I will add. Okay. Then 9 dots I will add. Understood? So try making a few triangles like this and making a pattern of triangular number. Still, if you have any problem, once again I want to say first, then 1 plus 2, then 1 plus 2 plus 3, then 1 plus 2 plus 3 plus 4, then 1 plus 2 plus 3 plus 4 plus 5, then 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. Understood? So these are our triangular numbers. Now, square number. Don't worry, nothing is difficult. It is very easy. Vidhi ma'am is there. Now, square numbers grow by multiplying the same number twice. Now, what is that? See, if I write 7. 7 into 7 is what? 49. If I write 3. 3 into 3 is what? 9. If I write 2, 2 into 2 is what? 4. If I write 4, 4 into 4 is equal to 16. What do you understand? These all are square numbers. Means by multiplying a number twice, we get these numbers. And we write it like this: 7 square, then 3 square, then 2 square, then 4 square. What does that 2 means? We call these powers. What do we call this? Powers. 2 means, here 2 means what? That this number is getting multiplied twice. Okay, I am writing 5 square. What does it mean? 5 into 5, that is 25. Okay, and what is this? This is the power of 5. Means 5 is getting multiplied by the number means itself twice. 5 into 5. This is the power, and this number, and this number, this number, this number, this number called base. Okay, now see what is given here. They always have a whole number. See, 1 square means 1 into 1 is 1, 2 square, and see, look at the dots, 2, 2. 3 square means 3 here, 3 here, means length and breadth. If we talk about what? Square. Yes, please don't understand that the square which we have learned in geometry, square and rectangle, these kind of, this is like we are squaring a number and giving example of a square. See, 4 and 4. We all have learned squares have same length and breadth. Here also 5 square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I hope now everybody understood what are square numbers. Okay. Look at the series. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. 1 is a square of 1. 4 is a square of 2. 9 is a square of 3. 16 is a square of 4. 25 is a square of 5. 36 is a square of 6. 49 is a square of 7. 64 is a square of 8. And 81 is a square of 9 and 10 and so on. Okay? Very good. Now the third number is cube numbers. No, these all are not new. Cubes everybody is aware of. You all must be playing that magic cubes. I am not aware how to play that magic cube. Please tell me if somebody gets time. I am not able to manage with that magic cubes. So now let's say cube. Cube is what? When we multiply a number. When we multiply, suppose I have been given 2, 2, 2. So 2 into 2 into 2 is what? 8. Okay. So 2 cube we can write, because 2 is getting multiplied for how many times? 3 times. 3 times now. 1, 2, 3. Now let's see. 3 into 3 into 3. What we can write? 3 cube, or I can write 3 3s are 9. These are 27. Now the next number, 4 into 4 into 4. I can write it like this or not. 4 cube. What is this? This is exponent, exponential power. And this is called, 4 is called what? Base. This is called base. This is called base. This is the base and this is the exponential power. I write 7 into 7 into 7. What I can write it? 7 cube. Means 7 is getting multiplied 3 times. Okay. So 7 into 7 into 7. 7 sevens are 49. And 49 sevens are, quickly. Yes, 7 nines are 63. 7 fours are 28. Plus 6, 343. Correct? Now, let's come to the page. Now, if we talk as a pattern, so 1 cube, only 1 cube is there. If I ask you 2 cube, then how many cubes are there? 1, 2, 3, 4, 5, 6, 7, and 1 is behind this. So how many cubes are in total? 8. If I ask you 3 by 3 cube, now whenever now you will have your cube in your hand, just count it how many cubes are there. 3 by 3 cube, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, 15, and so on. Total is what? 27. Then 4's cube, 5's cube, 6 cubes. Okay, don't be confused. If the number patterns are asked as a cube, always remember that the numbers are multiplied by itself, means it is multiplied itself 3 times. Okay, I hope everybody is understanding. Please, this is kind request, whenever we are studying, always sit with a pen or a pencil, and one register or a notebook is mandatory. Beta, it is kind request, whenever you are sitting, always sit with a notebook or register, means whatever you have, and make like a separate notebook for maths, so that whenever we have to revise it, we can go through it. This is my kind request, because we have to work in a proper method, that we should have one maths rough notebook. This is always my request to all my students. Whenever I was teaching in school also, I always requested a student to make a separate notebook or separate rough notebook for maths, where nothing should be done, only maths should be done. Whatever I am teaching, please take a quick note. Even if you are not able to understand, please revise it. And if you are not understanding, watch the video again, and still you are not able to understand, you just comment me. I'll make you understand in some other way. Okay, so I'll be there till the time you don't understand the topic, but you should also be willing to understand the topic. Okay, so now the next number in the series is Virahanka number. Name is quite strange. Yes, Virahanka was a, who was Virahanka? He was an ancient mathematician. So on his name, Virahanka name was given. So it is an ancient Indian sequence. We all have learnt about Fibonacci series, but it is similar to that, but not exactly, because in Fibonacci series and Virahanka number, starting values are different. Okay, so if we talk about Virahanka number, so this is the sum of previous, means previous numbers. Like 1 plus 2 is what? 3. 2 plus 3 is what? 5. 5 plus 8 is what? 13. 13 plus 21 is what? 34. 34 plus 55 is what? 89. And so on. So let's take once again one example. 1 plus 2 is what? 3. 1 plus 1 is what? 2. Okay. Now 2 plus 3 is what? 2 plus 3 is what? 5. Now 3 plus 5. 3 plus 5 is what? 8. Now 5 plus 8 is what? 13. 8 plus 13 is what? 21. Now 21. 8 plus 13 is 8 plus 13 is what? 21. So we will be adding it in a same way. Now please see the example. 1 plus 2, 2 plus 3, 3 plus 5, 5 plus 8, 8 plus 30, 13 plus 21, 21 plus 34, 34 plus 55. This is a Virahanka number series. Now next number in the series is power of 2 series. What does that mean? Power of 2 series means 2 we will take as base. Means 2 we are taking as base. What is the base? 2. Look at this. 2 is the base, 2 is the base, 2 is the base. I have already told you about base. Suppose this is 2 and I am taking this power 0. I am taking the power 1. I am taking the power 2. I am taking the power 3. So what is this? This 2 is called base. We have already discussed what exactly the base is. Okay, suppose some number is a and its power is n. So a is the base and n is the exponential power, exponent power. Okay, now 2 to the power 0. This also we have discussed that if any number whose power is 0, its value will be 1. Why value remains 1? We'll discuss some other day, or I'll make some other video. 2 to the power 1 is 2. 2 is uh, not multiplied. Now 2 to the power 2 is what? 2 into 2, that is 2 square. 2 to the power 3 is what? 2 into 2 into 2. Okay, if I write 2 to the power 8, what is its value? 2 into 2 into 2 into 2 into 2 into 2 into 2. How many 2's are there? 1, 2, 3 into 2. Means total 8 2's are there, means 2 is multiplied by itself for 8 times. Understood? If I am writing 2 to the power 4, what does that mean? 2 into 2 into 2 into 2. Okay, any number, it is not about 2, but in this we are talking about 2, so we are discussing only 2. So 2 will be taken as the base. See, n is what? N is the number of powers. So 2 to the power 0 1, 2 to the power 1 2, 2 square 2 into 2, 2 cube 2 into 2 into 2. And what are the values? 2 to the power 0, as I told you, 1, 2 to the power 1 2, 2 to the power 2 4, 2 to the power 3 8, 2 to the power 4 16, 2 to the power 5 32, 2 to the power 16 6. So means in this way we will multiply, and whatever the power comes we will multiply to that number of times. Okay, I hope everybody understood. Now, power of 3 number series. Now once again I just want to ask, power of 3 number series, what is the base here? Quickly, what is the base here? Base is what? 3. Base is 3. So now we are discussing about 3's power. 3 to the power 0, what will be the value? 1. Very good. Means any number will means is the base, and if the power is 0, the value will be 1. Okay. 3 to the power 1, 3. 3 to the power 2, that means what? 3 into 3, that is 9. 3 to the power 3, 3 into 3 into 3, that is 27. Okay, let me ask you, 3 to the power 5, how we will write this? 3 into 3 into 3 into 3 into 3. How many times I have written 3? 1, 2, 3, 4, 5. Means 3 is getting multiplied by itself for 5 times. Understood everybody? Now if I write 3 to the power 7, yes, you all have to practice with me, beta. Don't sit idle. Don't sit idle. If you will practice, I will tell you this thing, that it is not a story, that we, without practice we won't be able to survive in maths. These are the, like, what do I say? This is the truth for maths. If you will practice, then you will gain. If you will, like, listen once and you go and say ki, yes, I have listened to the video, I have listened to the teacher, and you are not practicing, then I can guarantee this, you will forget everything. So this is my kind request, dear students. Please sit with a register, pen, pencil, means whatever is required, and make a separate notebook, rough notebook or fair notebook, whatever you want. Make it and do all the sums with me when I am doing. Okay. Now write, what is 3 to the power 7? 3 into 3 into 3 into 3 into 3 into 3. How many times I have written 3? 1, 2, 3, 4, 5, 6. One more time. So 3 to the power 7. I hope everybody understood. Now let's see. 3 to the power 0, 1. 3 to the power 1, we can write like this, expanded form. 3 square, expanded form is 3 into 3. 3 cube, 3 into 3 into 3, and 3 to the power 9. How many times they are writing 3? 1, 2, 3, 4, 5, 6, 7, 8, 9. Understood? Then we will multiply 3 for those number of times. Okay? Every next number. 343 will be divided by 3. We will get the next number. 729 divided by 3. Sorry, multiplied by 3. We will get the next number. 2187 multiplied by 3. We will get 6561. Means if I have to get what is the next cube, the 1 into 3 is 3. Then like next number is 3 into 3, 9. 9 into 3, 27. 27 into 3. Okay, so we'll keep multiplying the number with 3 and we will get the next number. Okay, not cube, next number. Understood? 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 So we will multiply the number with 3, means this number, multiple of 3 with 3 to get the next term. But in the case of yeah, powers of number series, we will check what powers of 3 and what are the values of 3. If we are 3 to the power 5, 243, and so on. Okay. Now here are the few examples of the patterns which we have learned just now. What are that? All ones, look at the apples, 1 1 1 1, and see other images also. Then counting number, queue positions, house numbers, page numbers, means wherever we are using countings. Then odd numbers, look at the house numbers, 1 3 5 7, and all other examples also. Even numbers, pairs of shoes, two shoes, then four, then six, then eight. Okay, eggs also, and these are the examples. Now let's move to the next slide. See, the examples are given for whole numbers, counting peoples, and numbering the pages, house, floor, seats, one whole thing when we count. Okay. And then triangular numbers, look at the real life examples, look at the heaps, then squares, how do we use, cubes in real life, how do we use, and Virahanka numbers found in flowers, petals, leaves. Now look at the powers of 2 used in computers, memory like KB, MB, and all. Okay, and when we write some large numbers, we use powers. And then look at the powers of 3, how we are using. Grouping in threes, in sports, traffic lights, and means there are many examples where we can use powers of 3. I hope everybody understood what are patterns in mathematics. First part we have covered, and now next video I'll be uploading soon, where you can get figure it out questions and answers with explanation. Now for more educational video of mathematics where you can understand the next chapter also, but we will continue with the same chapter and I'll be explaining figure it out question answers. So subscribe the channel so that you can get the next video for figure it out questions. Then I'll be starting with the next topic of same chapter, patterns in mathematics. So dear students, to get more educational videos like this, please subscribe, like, and share. uh, Dear students, please don't forget to revise the topic which we have learned today. Okay, and please write all the questions, all the methods which we have discussed, and make a separate notebook for maths. Mathematics is everything about practice. The more you will practice, the more you will learn mathematics. Okay.